All right, welcome back. We're here at 5, and we're going to introduce this idea today about complex numbers and roots. And so, one of the first things we're going to do, we kind of talked about this earlier, is the number of roots. Look what happens if you try to graph x squared plus 1. Let's see what happens here. Well, you'll notice that just moves it up 1, and so we don't really have any zeros. So, there's no solutions. So let's try solving that a little bit algebraically. If we set that equal to 0, x squared plus 1 equals 0, we'd get the x squared by itself, which would be negative 1. And so x would be taking the square root plus or minus the square root of negative 1. And the dilemma that we have here is that you can't take the square root of a negative number. It doesn't exist. It's not a real number. So what we did is we kind of introduced the idea of, you know what, let's call that an imaginary number. Just like some of you have imaginary friends, there are imaginary numbers. All right, so we have x equals plus or minus. We're just going to say the square root of negative 1 is going to be defined from here on in as the letter I, meaning it's imaginary. Wow. Okay, so anytime we take the square root of a negative number, it's not real, it's going to be an imaginary number. Wow, crazy, kind of out there, a little abstract for us. We'll get that figured out and see how that works. So again, as we work here, kind of see how this works again, that if we're taking square roots of negative numbers, we got to incorporate an I in the answer as we go. All right, so let's take a look at how we would do this. 5 times the square root of negative 121. Well, we know that the square root of 121 is 11, plus or minus 11. So negative, it would have to be 11i. It would be the square root of that, so our answer would simply be 55i is what we would have there. Crazy, isn't it? Yeah, it kind of takes a while to get used to that a little bit. Let's skip over that one. Let's try this one here. We're going to take, oopsie, let's go back. I hit the wrong button. Now we know that the square root of negative 36, it could be plus or minus 6. So if it's the square root of negative 36, we know that that's just going to be 6i. So if we take 2 times 6i, that's going to be 12i. Crazy how that works. Let me put the dot on there so we know that's an I right there. Okay, there it is. All right, let's close that up. All right, now for solving x squared is equal to negative 144. We know to get the answer there, we've got to take plus or minus the square root of negative 144. Well, we know that the square root of 144 is positive or negative 12, so this would be plus or minus 12i is what we would have there. All right, crazy stuff. All right, let's solve this equation here. All right, let's get the 90 to the other side by making it there. We'll divide by 5, so x squared is equal to negative 18. So x would be plus or minus the square root of negative 18. Yeah, you could leave it like that, but again, we like to simplify. Remember, 18 is 9 times 2. The square root of negative 9 would be 3i. And then we'd still have a 2 in there, so you might see it written like that. Yeah, we always like to simplify it if we can. All right, let's try that. Okay. All right, now complex numbers are numbers. We have real numbers, we have imaginary numbers. So complex numbers combine the two of them. And we typically like to write the real number first, plus or minus the imaginary number is what we like to do there. So that composes of a complex number. Okay, so keep it, and that's where the phrase keep it real came from, right? We want to keep it real as we can. Sometimes we have to go imaginary on it. All right, so you got those. So as we do some of these equations here, you might say, okay, what values of x and y make this true? Well, let's think about this. The red are the real numbers. So all we have to do is figure out that 4x equals 2. Well, x has to then equal a half. The blue are the imaginary numbers because they have the i's with them. So we just have to say, well, 10 has to equal negative 4y. And we can just set those equal to each other and we can solve. Okay, so yeah, so we knew over here that 4x equals 2, so x is 1/2, if it's going to make that true. Here, the 10, the I is just the imaginary part, we don't need to include that. The 10 has to be equal to the negative 4y, so y would have to be negative 2.5 is what we would have to see there. Okay, so again, setting those parts equal to each other can make that solve. Let's try the same thing again. This time the real parts are right here, so let's just say 2x is equal to negative 8, so x would have to be negative 4. And then the imaginary part, negative 6, has to equal 20y. Well, y would have to be negative 6 over 20. If you want to put that as a decimal, you want to put -3/10 or -0.3. If you like decimals, that's okay. You can do it either way that you like. Okay, so solving those. All right, now last time it's section 5.4, we used the completing the square method to solve, and what we did is we kind of found out, okay, what's half of the b value, which is 5, squared is 25. All right, we add that to both sides. So we do everything the same way, except what's going to happen here today is that we're going to, as we solve this, we're going to get x, oopsie, let's do this, x plus 5 squared equals -1. So now we're going to get a negative number over here. So when we take the square root, we get x plus 5 equals plus or minus the square root of -1. And then getting x by itself, we get 5 plus or minus, well, the square root of -1 we know is just I. So there's our answer, 5 plus I and 5 minus I. And by the way, that's called a complex conjugate. We'll talk about that in a little bit, is that they always travel in pairs. If you have 5 plus I, you always get 5 minus I. Those are always guarantees when you do those, okay? They're like traveling buddies here. All right, so I think they just wrote that all in for us. We got it. All right, so let's try this one all on our own here. Let's see what we can do here. So completing the square, let's go x squared plus 4x plus blank. Let's put that 13 to the other side, making it negative. Whoops. And then let's go plus blank there. All right, so completing the square, that would be a 4 and a 4. So let's do this. X plus 2 squared is equal to -9. So when we take the square root, we get plus or minus the square root of -9. Well, we put the -2 the other side. We know that the square root of -9 is plus or minus 3i. There's that complex conjugate pair again, -2 plus 3i, -2 minus 3i. Always travel in pairs. You get one, you get buy two for the price of one, as we say. All right, so again, we kind of talked about this as the complex conjugate. This is going to be the easiest questions known to man. We said, okay, if you have -5 plus I root 10, it's complex conjugate. Keep the real part the same. We're just going to change the sign on the imaginary part. Notice how that part just changed. Those are just it. Those are his buddies. Those are the complex conjugates. We kind of saw those came together when we found solutions there. So we'll ask you some simple questions like this. What is the complex conjugate of 8 plus 5i? Well, obviously that's just 8 minus 5i. All right, what's the complex conjugate of 6i? Remember, we just change the imaginary part, so it's just -6i. You could think of it as 0 plus 6i and 0 minus 6i. So that's about as easy as it gets there. You can't get those